what we need to do is we need to once again solve for y in order for the equation to be in slope-intercept form. Thinking about the last one we did, what step will come first? Go ahead.
Add 3/4.
Good. The x. We need to move the x. We need to add the 3/4. So between the two of you, that was good. So we add 3/4 x to both sides. And we do always put the x part first once we've moved it over. So we're having 3/4 x minus 1. Now, what would be the next step on this problem?
Divide by 2.
Divide by 2. If I divide by 2, it's not going to get this. The reciprocal, good. Multiply times the reciprocal, good. So what is the reciprocal here?
2.
2. Or 2 over 1, right? The reciprocal of 1/2 is 2 over 1, which is 2. Okay, so we're going to multiply both sides times 2. Okay. We could have divided by something if you wanted to, but it just makes it more complicated because times 2 will make the 1/2 cancel out. 2 times 1/2, 2 times 1/2, okay, does cancel out, and that equals 1. That's why that works. So y equals, how much is 2 times 3/4?
That would be 6/4.
6/4, what's it reduced to?
6/4.
It would be, look, it would be 2 over 1. It would be 6/4, but there's an easier way to do that. What about canceling?
You're doing 2 and a 4.
Cross cancel. All right, now, if you need to use your calculator, you can, but I'm telling you right now, the skill as far as cross canceling, you're going to need that skill for something that's coming down the road. As you go forward in math, we're going to be simplifying polynomial expressions. Okay, and when you simplify polynomial expressions, you really have to get and understand this whole concept of cross-canceling. So this is my favorite way of doing that. That makes 3/2, except for it's going to be with a whole bunch of variables and things. But you can do it, but you really have to understand this cross-canceling idea. So 3/2 x minus how much? 2. 3/2 x minus 2. Now we need to graph it. So we need to make our x and y axes. Go. There we go. And you're going to make sure you label x and y. Where do we start this graph? -2 over here on the x-axis or on the y-axis? Y-axis. And what do you do next?
3 over 2.
Up 3 over 2. That comes from the fraction, the slope, up 3 over 2. Or also works the other way, down 3, left 2. And we draw our line. Okay, it's not finished until you actually draw that line.
Wait, how many points do we have?
The least amount would be 2, but it's kind of hard to get the straight line going right with 2. It's much easier if you do 4. But if you run out of space on your graph, as long as you have 2, you're good. All right. Now, my other question is going to be, what is the slope? And what is it?
3/2.
3 over 2. And the y-intercept?
-2.
As an ordered pair? 0, -2. Good. So we have our slope, we have our y-intercept, we have our graph. Okay? And that's great. Then we need to add on, not all of them are able to be put into slope-intercept form. There's a couple special ones, and so we need to take a look at the special ones. Okay, all right, God bless you. Here's our special ones. Our special ones are y equals 3 and x equals -5. This one turns out to be a linear function, and x equals does not turn out to be a linear function. And once we get the graphs done, we can talk about why this one is a linear function and this one's not a linear function. They both turn out to be graphs of lines, though. So, who knows what a y equals graph is going to look like? Is it going to be, is this a horizontal or vertical? Well, here's,
Wouldn't everything just be on the y-axis?
okay, well, here's the deal. The first thing you do is graph what it actually says, y equals 3. So I go on y and I go to 3. Okay? Then you can think about any other points that have 3 as the y part. Okay? So this is the ordered pair what? 0, 3. Give me another ordered pair that has 3 for y. 1, 3. That one goes here. Give me another one that has 3, 2, 3. Okay? So it's turning out to be what type of a line? It's going to be a horizontal straight line. A horizontal straight line. We can, but not for a y equals. Okay? The y equals will always be a horizontal line. So y equals just a number. Okay, will be a horizontal straight line. So my question is, this is actually in y equals mx plus b form. Y equals something x plus b. What's my something in this case?
1.
Well, 1x would be, there'd be a thing here. There'd be a 1 here, and we'd still have an x. So what must it be? How many times x to make it disappear? 0. Okay, this is really a 0x plus 3. You don't see the x is gone. What's the slope then of this graph? Slope is 0. We had said that before, but now we have to tie it into what the math looks like to go with it. Horizontal line has got a slope of 0. Okay? Even if we think rise over run, to go along a horizontal line, you're going up 0 and then sideways. So a slope of 0 will always be your horizontal line. Okay? Anytime you have y equals and it's just a number and you don't see the x.
I don't get why you graph.
I was showing where we were trying to establish, people couldn't remember, is it a horizontal line or a vertical line? So we were trying to establish by thinking about all of the ordered pairs where y equals 3. And the examples given were 0, 3. Somebody else said, well, 1, 3. Somebody else said 2, 3. And we could do that forever and ever and ever. And they're all the ones where y equals 3. And so I graphed 3 points, but I could have easily just kept on going, kept on going, kept on going. And it would show that the line actually is turning out to be this way. So my slope is 0. What's my y-intercept for this one? Ordered pair. 0, 3. So we've got our slope as being 0 for horizontal line, and the ordered pair 0, 3, the y-intercept is 3. Now this one turns out to not be a linear function. It's still going to make a line, but it's not going to be a linear function. The key word there is function. Who remembers what happens for an x equals something?
You get like a vertical line.
You'll get a vertical line. But let's show why. X equals 5. We go 1, 2, 3, 4, 5. It's going through that. But if we think of all the other points where x equals 5, we had 5, 0. We could also think of 5, 1. We could also think of 5, 2. Okay, we could also think of 5, 3. And on and on and on and on. You could keep on showing point after point after point where x is 5. There's no limit to what the y is going to be, but the x has always got to be 5 in this case. We draw in our line. We do confirm that we've got a vertical line here. And when we try to start answering our questions about slope and y-intercept, we get maybe a little confused, but not too much. What's the slope of this line?
0.
Not 0. It's undefined this time. Undefined because the run is 0. There's no sideways to it. Right. Exactly. Horizontal is 0. Vertical is undefined. And our y-intercept? Yeah, is there?
No.
There is, it's not even 0. There is none. Because it never crosses the y-axis. So there is no y-intercept for this type of a thing. And why is it not a function? It doesn't pass the vertical line test. Excellent. Because you have one vertical line here that's got billions of points on them. So it like fails it big time. So it's not a function. It's still a line, but it's not a function. That's only ones where you have x equals and there's no variable. There is no y. The ones that are y equals with no x turns out to be horizontal. And those were two special ones. They did not have examples of those in your book, but then they ask you to do problems on them, so I felt honor bound to actually include that in there. All right.